All right, welcome everybody to episode 2 of the whole Science Matters new part of the YouTube channel. And one of the things that I found when I started doing the science content was that I get a lot of email from people saying, well, scientists will cover for each other. If they get something wrong, they'll never admit it. They'll always just throw more math at it or something. Or they'll say whatever their funding agencies want them to say. That was my other favorite one. So I asked Doug to come on for a reaction on this one because we have earlier this week there was, if you watch the science news, there was a group that published the thing that's coming up in an early 2025 edition of Astroparticle Physics. Don't worry, I'll leave the math out of this unless Doug actually wants to see it, in which case we'll be happy to talk about the math.
Maybe we don't bore the viewers, but boil it down.
Well, the thing they're trying to do is link quantum physics and general relativity for this grand sort of one size fits all group of physics laws. And that's been the goals of physics kind of forever, is to kind of come up with one set of rules that kind of describe how nature works for all instances. Now, Newton described classical mechanics, which are kind of bigger objects moving slower, friction and cars and all that kind of obey Newtonian mechanics. Quantum mechanics is all the atomic stuff or things moving super crazy fast or heavy gravity fields like um, fun things like black holes and whatnot. But how do you link all that? Because what works in the quantum world doesn't work within relativity in some edge cases. So how do you get those two to kind of work together so that you don't have those errors? And there's been a big conjecture in physics whether the Einstein, you can see right here, another conjecture in physics is whether the Einstein-Rosen bridge and the Einstein-Podolsky-Rosen entanglement are physically equivalent. And what that means is, can you kind of move from one universe to another, among other things? That Einstein-Rosen bridge caught a lot of attention during Thor, I think it was, which Thor never explained the physics of it. And we're not going to either because I'm still not sure you can get between galaxies. So this whole thing has to do with quantum loop gravity. I mean, string theory, you name it, this is what's in this stuff. And this made a lot of news because if you could really unify those two, if you could really kind of tie those together, that's what physics has been looking for years. And this gets into muon. This is crazy heavy math, right? So this is nutty stuff. And Astroparticle Physics Journal went, holy crap, they've got it. And they sent out a bunch of preprints. So when the actual journal comes out, this will be part of it. But in the science community, you get these preprints online so you can kind of look at it ahead of time. And this made it through. This was, I think last week this came out. A lot of science press kind of caught this thing. Yesterday, Astroparticle Physics on September 10th issued expression of concern about that very article. And what they're saying is this is a note of temporary expression of concern related to potential errors in the formulas on this paper. This concern and note will remain appended to the above-mentioned article until the investigation is closed and a decision is made regarding the article retraction or correction. That's the scientific version of, oops. That's not quite right,
The
guys.
editor quick to push things out without having it double, triple, quadruple checked, or how's that happen?
It made it through peer review. So I've read part of the paper. It's heavy physics, right? So I've read it, but I've not really gone through and checked the math. So there's two versions of reading a physics paper. One is you read the words and you kind of just assume the math is correct, and the other one is you go back and check the math. And checking that math is a full-time job for a lot of people, right? It's not something you're going to do quickly. So Astroparticle Physics Journal is peer reviewed. So this made it through peer review, and the peer review process missed something until it hit online, and then everybody went, wait a minute, and they took a closer look. My guess is, and I'm going to dig deeper into it, is they made something and said, we're going to make this assumption, which a lot of science papers do. And assuming this is true. Well, sometimes assumptions are, just that they're assumptions and they're not valid. And what they're trying to say is, look, we proved it all. And my guess is they either forgot to include an assumption or they made an assumption that renders everything invalid. But I think this is an important point. And Doug, I think it's good to have you on because your dad was a doctor, and one of the things I hear about all the time is, well, COVID and all these other things that happen. Science in general is not, exacting. It's like, hey, here's exactly what we know today, and here's this set of rules that we think will work to solve this particular problem, and let's apply that to the situation, and let's go, right? And when your dad was a doctor, they call it practice medicine, right? Because you're not always right. So sometimes you get it,
Right,
sometimes
right.
you don't. And there's statistics to it all. It's like, well, 90% of the time you see these symptoms and that's the disease. And you just kind of say, okay, well, it's probably that, and you move on. And sometimes you're right and sometimes you're wrong. So science is never exact. You never know everything. You can never know everything. That's why you want to keep digging in and understanding it more and more and understanding it better and better. And scientists do get it wrong on occasion. And there was a time in the world where we thought, you know, there was nothing smaller than like the stuff we could see or the plastic in the mouse. And then we figured out that, hey, there's the atom in there. And that was a long time ago. And then until the late 1800s, we figured the atom was the smallest thing that existed. And then all of a sudden, people start pulling all kinds of crap out of it with, electrons and protons and neutrons. And we're like, holy crap, the atom's not the smallest thing anymore, right? And that was less than 150 years ago. And then all of a sudden, people were like, hey, about those protons that we said were the smallest thing ever. Just kidding. We found more, right? So they're made up of quarks and little tinier particles. And nobody's really quite sure what to do with quarks yet. But we know they're there. So now what do you do with them? Well, who knows? But did we know what to do with the electron when we first found it? Well, no, but now my computer and my CCD camera work, right? So we figured out something to do with those electrons. But I think the important thing to know is that if science done properly, has a community of people who will rat each other out when they're wrong, and they don't care. So, hey, it's kind of, I hope, like if I'm going to publish something, like back when I worked in the nuclear physics world, if I'm wrong, I hope people walk up and tell me I'm wrong, because you don't want to go run a nuclear reaction and get the stuff incorrect, right? You want to be right, or bad things could happen. So,
Well, in any profession, there's going to be a level of, because it's a human being, there's going to be a level of ego involved, right? But I definitely think it's less in the scientific community. I know it was obviously at least from my experience in the medical community, from my father's perspective, there were doctors who cared about treating the patient, getting down to the bottom of it, and those who cared about being right. So you have that as well, I think, probably going here, but probably more. I mean, not to drop the analogy for a moment. You said peer review. That's interesting. That's something I didn't realize with this article. It went under a peer review before it went out. So,
mhm.
like you said, they're looking to catch anything because they want to profess the truth, and it's not just a system where one author can scream the sky is falling so they can get attention, like our constant social media. But that's a different topic.
You can. I mean, there are a couple servers out there. I could write a paper now and upload it to that server, and people can start reading it now. And there's a bunch of them out there. They're called preprint servers. This one though was actually set to appear in the astroparticle physics, and it caught a lot of attention. Wow, the grand unified theory. Because if you could truly figure that out, you could figure out black holes and you could figure out gravity and all some of these other things and tie it all together. Can you actually get a wormhole to function? That's a big deal. Because if you can, maybe that faster than light travel thing actually could kind of become a reality.
Right.
And that was kind of what that paper was trying to say is, haha, we're there, you're not, suckers. And then somebody was like, agree to disagree. But I'm going to go back and actually look at the math as soon as I have enough alcohol in my system to tolerate the math. I'm just kidding.
It changes chemistry to do the math.
This is not Kidden level math, right? This is Einstein Rosenbridge level stuff. So if any, and what kills me about journal articles is they'll make these leaps in between one step and another, and there's like 50 steps of math in between here and here, and they never show you the 50 steps. So you have to actually go back through and work it out. But it's done for the space purpose. But there's your famous equation, right? Just slightly rearranged. But they've got some interesting stuff here that when I first saw this paper, I was like, huh, that's really interesting. I'm not sure I buy up on it yet, but it's really interesting. And then, other people apparently did the same thing where they said, oh, I'm not buying off on it yet. And apparently somebody got back to astroparticle physics and went, hey guys. And my guess is the correction is now undergoing peer review to see who's right and who's wrong. But I'm going to bet they're going to use different peer reviewers this time.
Sure, of course. We should hope so.
So I don't know, Doug, does something like this, restore or help you at least restore a little faith in the scientific community or stuff like
It
this?
does because,
Yeah.
like you said, the journals that are of importance are to have this system set up in place, right, for peer review.
Right.
And they're willing to call themselves out, which you know, in other industries and other people are all it's all about their ego and their what's the word I'm looking for, their
Perceived
perceived
value. Right.
viability, and so to
Right.
admit fault is something that these other outlets would not do. So it's really great. It's actually good to see this.
Yeah. And I can't remember the last time Astroparticle Physics was making actual news reports. But all of a sudden it was, all of a sudden it's like, oh yeah, oops. So,
Yeah,
um,
just let's hope that, I mean, the scientific community gets it. Let's just hope that the greater audience sees it as oh, okay, let's get to the bottom of this, and not a see they were wrong. Well, they called themselves out. It wasn't like they were trying to hide the fact. So.
yeah, I mean, I was reading this book recently that has some interesting points in it. It's The Demon Haunted World. It's a Carl Sagan book. And Sagan brings up some interesting points. And I think stuff like this, where you disprove things or say, hey, look, you got it wrong, is important. Because I think it does kind of help people have that sort of confidence that the scientific community will call each other out if necessary. So he brought up an interesting point that somewhere in here that there was a time in the United States even where we had witch trials and
Right.
we were burning people at the stake because they were doing things that we couldn't explain. So of course it must be witchcraft. It couldn't possibly be another explanation for what was going on, and it turns out it wasn't witchcraft; it was something else. Oops, sorry, we burned a couple of people. So, but it's like the old saying: anything sufficiently advanced technologically or science-wise can look like magic. But there was a time when they didn't think to sterilize surgical instruments, and they just went ahead and did surgery, right? And then somebody figured out, hey, if you boil them first, people don't get infections, right? Um, there was a time not terribly long ago, Revolutionary War period, where leeches were a great response to a fever.
Mhm.
Where take even Civil War, which is 150 years ago. Um, oh, you got shot. Well, we better cut the leg off, right? I mean,
Right, right.
it's kind of the solution to the problem. And we've come a long way technologically, and I think people kind of take it for granted now that you can kind of make anything work because in the last 30 years, I mean, I grew up in the 70s and 80s where, we didn't have modems or computers, and I was still in the garage tinkering with shit, and I shocked myself many times because I was still tinkering with stuff. Um, which was always fun. It's like, oh, I'm going to go build a radio. No, I'm not. That hurt. I did successfully build several AM radios. They just weren't very good. So, um, but uh, we've come a long way in even 50 years. And now I think
Sure.
people just kind of are like, well, I just go on Amazon and order anything I want. So scientists must be slacking. Well, no, I just think 20 years ago, the iPhone wasn't the iPhone, right? It was the iPod. Um, you didn't have the ability to make the phone. We still had landlines 20 years ago, and that's just
Mhm.
20 years. 9/11, we couldn't, not everybody had cell phones even, so you couldn't like find your loved ones. And well, cell phone towers were down in New York, but I remember in Dallas, uh, or where I was trying to call during 9/11, and that was just, today is 9/11, so it's on my head. Circuits filled up fast on cell phones, and not everybody you wanted to reach out to had one. And that was just what, 23 years back?
Yep.
So this technology stuff, while we do criticize it and we criticize those working in it for not being absolutely perfect, cutting edge stuff is never perfect, right? It takes a while to come around. And I'm glad to see these guys going through and saying, I don't care what the journal that I just published in says, and I don't know who's disproved it yet, but I'm going to guess it probably wasn't the authors. It's probably somebody else. But the scientific community did come forward and say, nah, not so fast. Which is
Which
kind
is
of
the
cool.
important part of this whole thing, owning
It,
up and then going back for, yeah, to actually get down to the truth.
and the coolest one of these I've ever seen, where somebody disproved something was there was a thing called molecular electronics a bunch of years ago, back in the early, right after the sort of, we went from the 20th to the 21st century, late 90s, early 2000s, called molecular electronics, where they're trying to make electronics out of molecules because you can make them smaller than you can make the electronics in your computer, and that's how you got faster. And it was a huge deal. Funding agencies were pouring money into it, and the people who started it were getting huge amounts, huge piles of money. And uh, Professor Reed over at Yale was part of that whole thing. And then a couple of years later, he went in the lab and figured out that it was all a giant mistake and they screwed up. And he himself published a paper that disproved all of his work for the last 5 years. And he did it on the front cover of like Science magazine. So
That's full responsibility. I mean,
he didn't he didn't pull punches. He's like, I fucked up, man. It's just the way it works, right? You have to give him credit for that. He didn't return
absolutely.
some people's phone calls for about a week after that, but he did do it. So um, he was very difficult to get on the phone. So I actually wanted to talk to him. I had to call one of his grad students and get over to it. But um,
Not
it
a great week.
yeah, that's what he says. He's like, dude, I'm busy. It's like, sorry, didn't mean to get it. I was going. But I'm kind of glad to see this kind of stuff. And I hope we, as a scientific community, I hope we do try to push those boundaries. And one of the other things about this that's interesting to me is a lot of times people will do safe science. And what I mean by that isn't that it's going to explode or, cause a huge problem. They'll do things that they just kind of know are going to work, right? You'll do things like, oh, I know this to 90% accuracy, so I'm going to go improve that to 91% accuracy. And they'll do something kind of safe. This was cutting edge. I mean, for theory work, this was a giant leap, and somebody took a shot, and I think they kind of screwed it up. So,
Well, but that's what we want, right? Because keep screwing it up until you get it right.
yeah, and I'd like to see more people swing for the fences,
Yeah.
because those are the ones that make a huge difference. Because remember, there was a time Einstein published his four famous papers in 1905, and those were relativity, photoelectric effect, and something else. General relativity, special relativity, second one on special relativity, and photoelectric effect. And he won the Nobel for photoelectric. But that year, those four papers, we now look at it and go, "Oh, that's Einstein's career year. It's all perfect." They weren't really that well received when they were first published. A lot of people were like, "No," and he and Niels Bohr used to have these fights going back and forth about what was right and what was wrong. So it does happen, and it takes time for this stuff to become sort of well known and less critical. So. Anyway, that was my whole point today, but I was excited because somebody disproved one that even I was reading going, something seems weird. But it was kind of cool. So, Doug, I appreciate you. And I want to point out your new Star Wars posters in the back. Uh,
Originals.
yeah, Doug's about to hit a milestone birthday at a half a century, which he had hair for some of that time, I'm sure. But
First, third.
so I do love the Yoda thing on the shelf behind you, by the way. Anyway, so everybody have a great day. We'll see you on the next video, but I wanted to throw one out there that said, hey, we don't always get it right. And when we get it wrong, it does happen. So see
Best
you on the
up and
next
we keep
video.
going.
Yep.